Let's discuss some factors which affect the rate of reaction. As the rate of reaction is determined by some chemical processes. So this means that it should be affected by some factors. As these factors includes nature of reactant, concentration of reactants, surface area, light and temperature. We will discuss turn by turn each factor that how they affect the rate of reaction. First, we will study about the nature of reactants. As the more active reactants, they will give the fast rate of reactions, means they will decompose fastly or they will react fastly, as the number of electrons present in innermost shell affects the reactivity of reactants. As if it have the more electrons, so it will be more excited reactant. As the elements of group 1A are the more reactive than 2A. The neutralization reaction and decomposition reactions are very fast because in the decomposition process is always the active reactants take part and they always decomposes very fast and gives us a fast rate reaction. As oxidation reduction reactions are slower because in this the gaining and losing of electrons and atoms occurs. The ionic reactions are very fast because in this reaction the ions take part and there is a very large amount of power of attraction between the positive and negative ions, so they gives us very fast reaction. The second method is concentration of reactant. As the reaction is due to effective collision of reactant molecules, so this means that when there is a large concentration of reactants, the effective collisions will be more occur. So the rate of reaction will be high. It is the same as if there is a room filled with only 4 people, there will be nothing happen among them. But if the same room will be filled by the 100 people, they will start fighting, they will start arguing, and in this same way the reactions occur. When the concentration of reactants is high, the collisions will be high and the rate of reaction will be fast. In the case of reactants in gases, their concentration is increased by increasing their partial pressures. And the rate of reaction is always directly proportional to the concentration of reactants, as this statement always refers to the first point we discussed in this method. Sometimes the concentration of reactant becomes double and the rate of reaction increases 4 times. We have third factor, which is surface area. When the surface area will be greater, then there will be a greater chance of contact of molecules. As the greater surface of area of molecules, the greater will be the rate of reaction. The fourth factor is light. As light travel in form of photons, as the photons have energy depending on the frequency of light, so when the energy is inherited on the reaction will be fast up. As the light gives the energy to the reactants to form the activated complex in the minimum time, as that activated complex always help out to increase the rate of reaction. So this statement means the light increases the rate of reaction. The last factor is temperature. As by increasing temperature, the number of collision of molecule increases. This is just because of increase in kinetic energy. As the rate of reaction increases by increasing temperature of reaction, on increasing temperature by 10 Kelvin, the rate of reaction becomes doubles. As the Arrhenius equation, which is given as K is equal to AE minus EA over RT, this gives us the quantitative effect of temperature on the rate of reaction, as the application of this Arrhenius equation helps us out in every way to find the analysis of the effect of temperature on the rate of reactions. We will discuss in the further topics.